Hello, my name is Andrew Brukewitz, and this is my lab report for Lab 2 for Physics 2212, working again with charge tapes. Here is a short overview of a few of the topics that I will be addressing in this lab, starting with an introduction where I'll go over main concepts, principles, and some assumptions. Then I will go into the results of the lab, followed by finally answering a few of the discussion questions. The main purpose of this lab is to produce a computational model of two charge tapes. These charge tapes repel each other, and in the last lab we did something similar. However, this time we will be modeling the tapes as rods instead of point charges. We will then use that model that we generate to estimate the necessary amount of charge on each tape to float one above the other and compare that to the estimate that we generated in the first lab. A few key concepts in this lab include Newton's second law of equilibrium, which is F equals ma, and then equilibrium is when the net force is total to zero. Coulomb's law, which gives us the electrostatic force, electric field, and then superposition of electric field. In this lab, we will assume that there is no air resistance, that each U-tape has the same charge, evenly distributed across its length, and that we can model it by splitting into small segments which sum to the total charge. Initially looking at the results from this lab, so the charge that we recorded in this lab is significantly larger than the charge recorded from lab 1, and this charge makes the force of gravity equal to the electrostatic force. In the diagram on the left, you can see the setup of the lab where we hold the charge tape A below charge tape B and eventually cause it to float. And on the right, you can see my results from lab 1 modeled as 2-point charges repelling one another. Here is a segment from the GlowScript code that I used for this lab to generate my models. We can see initially me coding in the experimental constants as well as the observed measurements from the scenario that was shown in the last slide. And additionally, at the bottom, you can see the estimated net charge on one tape, which is different from the last lab. Next, in this segment of code, you can see functions that we use to generate electric field and to generate the line charge model, which we use instead of a point charge in this model. Finally, this slide displays the end result of this lab. As you can see the blue and red tapes modeled as line charges next to one another. We can see the vector arrows of the electric force on the red tape that keeps it floating against the force of gravity. We can also see from the output that the magnitude of electric force of 2.5 newtons is approximately equal to the magnitude of gravitational force, which is also 2.5 newtons, which keeps it floating. And finally, the magnitude of line charge is 1.2 to the negative 10th coulombs. Lastly, going into the discussion questions that were posed for this lab, looking back at what we expected from our results and what differed. Starting with question 1, which asks us what would happen if we had modeled each of our tapes as a single point charge, as in the previous lab. So the magnitude of the point charge in the previous lab of 1.8572 times 10 to the negative 9 coulombs increases in this lab by a factor of 6.49 to 1.205 times 10 to the negative 8 coulombs. So if we had modeled it as a point charge, we would have gotten a lesser magnitude for that charge. Next, we want to ask why these estimates differ. The main reasons that these estimates differ is because they are simply different ways to model the electric force, and spreading the charge along the length of the tape in small segments does increase our precision. So the line model is ultimately more accurate because it splits the tape into smaller segments, and this is the estimate which we trust more.